In July 1994, the entire world watched one of the most extraordinary events ever witnessed in the history of astronomy. But before we begin, imagine a terrifying alternative. Imagine astronomers announcing that a giant comet had shattered into more than 20 massive pieces and was heading directly toward Earth. Imagine hearing that the fragments would not strike all at once, but one after another over the course of an entire week. Governments would declare emergencies, millions of people would flee major cities. Television stations would broadcast nonstop coverage. Every conversation on Earth would revolve around a single question. Would humanity survive? Families would gather together, uncertain about the future. Scientists would calculate impact zones, while world leaders prepared for the unthinkable. Thankfully, that nightmare never became reality. Instead, the target was Jupiter, the largest planet in our solar system. Yet what happened between July 16th and July 22nd, 1994, was so dramatic that it forever changed the way humanity viewed space. For the first time in history, people would witness a major collision between celestial objects as it happened. The event involved a shattered comet called Shoemaker Levy 9, and the impacts would reveal the incredible violence hidden within our seemingly peaceful solar system. More importantly, they would serve as a warning that the forces which shaped planets billions of years ago are still active today. The story began in March 1993, when astronomers Carolyn Shoemaker, Eugene Shoemaker, and David Levy were conducting a routine survey of the night sky. They had discovered many celestial objects before, but this one was unlike anything they had ever seen. Instead of appearing as a normal comet with a single bright nucleus, it resembled a glowing chain stretched across space. Through telescopes, the object looked like a string of pearls drifting through the darkness. At first, the astronomers were confused. Comets simply were not supposed to look like that. As more observations were collected, the truth slowly emerged. Years earlier, the comet had passed dangerously close to Jupiter. The giant planet's gravity had become so powerful that it literally tore the comet apart. This happened because the comet crossed within Jupiter's Roche limit, the distance where tidal forces can overwhelm an object's structural strength. The once solid comet shattered into more than 20 major fragments. Some pieces were estimated to be several kilometers wide. Scientists soon calculated the orbit of the fragmented comet and made a discovery that stunned the astronomical community. The fragments were not merely passing by Jupiter. Every single one of them was on a collision course with the giant planet. For the first time in history, humanity knew in advance that a major planetary impact was coming. As news of the discovery spread, excitement swept through observatories around the world. Astronomers understood that they were about to witness something unprecedented. Throughout history, scientists had studied impact craters on Earth, the Moon, and other worlds. They knew collisions played a major role in shaping the solar system. However, no one had ever watched a major planetary impact unfold in real time. Suddenly, the scientific community had more than a year to prepare. The Hubble Space Telescope was directed toward Jupiter. Ground-based observatories organized special observation campaigns. Radio telescopes, optical telescopes, and infrared instruments were prepared for the event. Researchers debated what would happen when the fragments struck. Some believed the impacts would be relatively small and disappear beneath Jupiter's thick clouds. Others predicted giant explosions that could alter the appearance of the entire planet. No one truly knew because nothing like this had ever been observed before. As July 1994 approached, the anticipation became intense. Scientific journals filled with predictions. News organizations began reporting on the upcoming collision. Amateur astronomers eagerly prepared their telescopes. Across the globe, millions of people waited for a cosmic event unlike anything humanity had ever witnessed. Finally, on July 16, 1994, the first fragment reached Jupiter. Known as Fragment A, it slammed into the giant planet at approximately 60 kilometers per second, or more than 200,000 kilometers per hour. Because the impact occurred on the side of Jupiter facing away from Earth, astronomers could not directly see the collision itself. Instead, they waited anxiously for evidence of what had happened. Soon the answer arrived. Massive plumes of superheated gas erupted high above Jupiter's cloud tops. As the planet rotated, the impact site came into view. What astronomers saw exceeded expectations. A giant dark scar stained Jupiter's atmosphere. The mark was enormous, far larger than predicted. Instantly, it became clear that the impacts would be much more dramatic than many scientists had expected. Over the next several days, additional fragments followed. One after another, they plunged into the giant planet's atmosphere. Each impact generated tremendous explosions. Towering plumes rose thousands of kilometers into space. Shockwaves spread through the atmosphere. Dark scars multiplied across Jupiter's colorful clouds. The giant planet began to look as though it had been struck repeatedly by cosmic artillery. Even amateur astronomers could see some of the scars through modest telescopes. Among all the fragments, the most famous was Fragment G. Scientists had expected it to produce one of the largest explosions, and they were right. When Fragment G struck Jupiter, the resulting blast released an almost unimaginable amount of energy. Estimates suggested it equaled several million megatons of TNT. To put that into perspective, the explosion was vastly more powerful than any nuclear weapon ever created by humanity. The impact generated a gigantic fireball and launched material thousands of kilometers above the atmosphere. Temperatures soared. Infrared instruments detected glowing regions hotter than anything normally observed in Jupiter's upper atmosphere. When the impact site rotated into view, astronomers were stunned. The scar left behind was larger than Earth itself. Imagine seeing a wound on another planet so large that our entire world could fit inside it. That was the scale of destruction unleashed by Fragment G. Around the world, researchers watched in amazement as the giant dark mark expanded across Jupiter's atmosphere. It was one of the most dramatic scenes ever recorded in planetary science. As the impacts continued, scientists realized they had been given an extraordinary scientific opportunity. The collisions acted like giant probes, briefly exposing parts of Jupiter's atmosphere normally hidden from view. Researchers analyzed chemical compounds carried upward by the explosions. They measured temperatures, tracked atmospheric motions, and studied shockwaves traveling through the clouds. Every impact produced valuable new data. The event revealed details about Jupiter's composition, weather systems, and atmospheric structure that might otherwise have remained unknown for decades. Yet while scientists focused on research, the public remained fascinated by a different question. What if Shoemaker Levy 9 had struck Earth instead? The answer was deeply unsettling. Even a single fragment several kilometers wide could have caused a global catastrophe. Entire regions could be devastated. Massive earthquakes and tsunamis could occur. Dust and debris blasted into the atmosphere might block sunlight for months or even years. Agriculture could collapse. Food shortages could spread worldwide. Civilization itself could face a severe crisis. Watching Jupiter absorb those impacts allowed humanity to visualize a danger that had previously existed only in scientific calculations. The event also reminded people of Earth's own violent history. 66 million years ago, a giant asteroid struck near present-day Mexico and contributed to the extinction of the dinosaurs. Before 1994, that catastrophe often felt distant and abstract to the general public. Shoemaker Levy 9 changed that. Suddenly, people could see what a major impact actually looked like. The collision demonstrated that the solar system is not a calm and unchanging place. It remains active and dynamic. Objects continue to collide. Worlds continue to be struck. As a result, the impacts transformed scientific attitudes toward planetary defense. Governments and space agencies began taking asteroid threats more seriously. New surveys were launched to identify potentially hazardous objects. Telescopes were dedicated to tracking near-Earth asteroids and comets. International cooperation increased. Decades later, scientists would even test technologies designed to alter an asteroid's orbit. Many of these efforts can trace their origins to the lessons learned from Jupiter's dramatic encounter with Shoemaker Levy 9. The event turned a theoretical danger into something visible and real. More than 30 years have passed since the impacts, but the images remain unforgettable. Dark scars larger than Earth drifted across Jupiter's atmosphere, long-lasting reminders of the tremendous power unleashed during that extraordinary week. The collision of comet Shoemaker Levy 9 with Jupiter between July 16 and July 22, 1994, was far more than an astronomical spectacle. It was a historic scientific experiment, a warning from the universe, and a reminder of humanity's place in a vast cosmic environment. Jupiter's enormous gravity may have saved the inner solar system from those impacts, acting as a giant shield that absorbed the blows instead of allowing them to threaten Earth. Whether viewed as a scientific breakthrough or a cosmic warning, the event remains one of the greatest moments in modern astronomy. For one unforgettable week, humanity watched as a broken comet slammed into the largest planet in the solar system. Explosions larger than nations erupted into space. Scars bigger than Earth spread across Jupiter's clouds. And the universe revealed a simple but powerful truth. Space is filled with wonder, but it is also